we're going to be looking at inverse functions and what represents the inverse function of a relation, and just basically we're going to dive into inverse functions. So here we're looking at enVision's Algebra 2 topic 5-6 example 1. So topic 5 has taken us into a lot of different directions. We saw some exponents, we saw some radicals, we saw rationals. With radicals, we've seen compositions, we've seen a lot of things. So we're going to see inverses in this one. So let's start with a table. So I'm going to start with a table of points, an x and a y. And in my table, I have the values -2 for x, -1, 0, and 1. For y, my output is going to be 1, 4, 3, and 1. Where x is my dependent variable and y is my, where x is my independent variable and y is my dependent variable. That means y depends on x to get its output values. So if you remember, we input x, that's supposed to be an arrowhead, that's a horrible arrowhead, into a function, and we get out your y value. All right, so x is my dependent, it doesn't depend on any other values, y is my independent. So recall that the relation is any set of ordered pairs, x and y, so we have a set of ordered pairs, we have 1, 2, 3, 4 ordered pairs, where x is the independent variable and y is the dependent variable. An inverse relation is formed when the roles of the independent and dependent variables are reversed. So it's basically the role when the independent then becomes the dependent and the dependent becomes the independent. All right, so in this inverse relation, we have 2, -1, 0, and 1 as our independent values. We have 1, 4, 3, and 1 as our dependent values. So I'm gonna take the inverse. So the inverse relation is going to be, again, just my x's become my y's. I don't know why I decided to draw a t-table here and not a t-table there. And my y's become our x's. So in other words, our inverse relation is x equals y or y equals x. All right, so everywhere where my y's are, so 1, 4, 3, and 1, those now become my independent values. My independent values, or my x's, now become my dependent values. So you switch the values of x and y. It's just that simple, that direct. Now looking at this one, we actually have two values that we have the same x. And if you remember back to Algebra 1 about the one-to-one relationship and that being a function, that you have to have that one-to-one relationship for you to have a function, we see here that in these 2 points, the point 1, -2, and the point 1, 1, we have 2 outputs for the single input. So this right here, this inverse relation, is not a function because we have 2 outputs for a single input. So if the inverse relation of a function f is itself a function, if an inverse relation of the function A-F-U-N-C-T-I-O-N, you guys get to hear me spell, f is itself basically a one-to-one, a function. So one input with one output, it is called an inverse function. So inverse function. Fancy T. I wrote a space there, T-I-O-N. All right. And the way we write inverse functions is we use this denotation, f of -1 of x. So let me write that a little clearer. We write the inverse function as f of -1 of x. So when you see the f of -1 of x, we're asking if this is going to be an inverse function. We have an inverse relation that does not translate into an inverse function. So an inverse function would be something like if I had x and y, and I'm going to go with -2, -1, 0, 1, 2. Y is going to be 2, 3, 5, 7, and 0. So if I were to look at this and I were to take the inverse, put it basically through an inverse box, where your x's become y's and your y's become x's. So in other words, you have x and y. So it went through here. All these values then became an x. And all of these values on your x now become the y. And then if I were to reorder this, you should always reorder. You have x and you have y. So this is 0, 2, 3, 5, 7. 0 has 2, -1, 0, 1, 2. And I'm looking at this, and each one of my points here is a 1 to 1. Unlike the last example, that was a 1 to 2. So we have one input and one output. One input, one output. And so this right here, my inverse relation, would also be an inverse function. So this right here would be f -1 of x. So always look for the relationship. If you have two distinct values in the domain of f, or if you have one x with two outputs, one single value of x with two values of y associated with it, then it is not a function. F is not a function. That goes back to that idea in Algebra 1 or pre-algebra, where you saw what the definition of a function actually is, or what the definition of an equation actually is. All right, so I hope you learned a little bit about the inverse relation in this example, and I will catch you in the next example.